Last week we looked at building blocks for expressions, which included the concepts of variables. And this week we're going to look at how App Inventor uses data in their program. So data in App Inventor could be built into components, or it could be parameters for events. So that's built-in data. Or you can create variables to hold data that you decide that you need. So you can create both local and global variables. Well, let's take a look at the data that's in properties of components. So a component has a lot of properties tied to it. Every property is data. So for example, is this text box enabled? That's data. Well, what we're interested in for our programs are what is the input, and the input into text boxes will be stored into the text property of a text box. So you do not even need to create a variable to hold that data because the text property holds that data. Data in a component or properties can be set at design time by just coming here and setting the values, or it can be set at runtime. The primary purpose of a text box, again, is to get input. This is design time, where you can grab your components and add them to your screen. And here we're testing in the emulator. This is runtime. Two text boxes are shown here, but they do look a little bit different at runtime. This text box is for input. This text box is for output. Normally you don't want your user to be able to click inside something that's for output, so the enabled property is not set. It's not enabled, in other words, and so the user can click in here and enter a value, but will not be able to click in here. This button is called button read input. When this click event occurs, everything inside of here will execute. This is what an assignment statement looks like to App Inventor. Well, let's review what an assignment statement looked to us last week and compare it to what App Inventor does. So we did something like this last week, and an assignment statement will, if you recall, have this operator that I will say is assign the value to. It's the assignment operator. It looks like an equal to sign. Many people will read this as x equals 10, or you can read this as x is assigned the value of 10. So I'm just assigning literal to this variable x, but this could be an expression. Okay, here we have an expression, and 10 times 4 will execute, giving me the result of 40. So x will now contain the value of 40. There are two parts to this assignment statement, what's to the left of the equal to sign and what's to the right. The way an assignment statement works is the right side executes first, gets a result. That result is then stored in the variable x. Something similar is actually happening here. So instead of a variable, as we said, text can hold data. So this would be similar to our x. The text property of text box output will store the value of the text property of text box name. So if someone keyed in A, okay, and that was it, and clicked on that button, this assignment statement will execute and A will display here. Pretty simple program. Let's take a look at how App Inventor does math then. In App Inventor, you will have some built-in blocks, and you will also have blocks that are on your screen from the components that you added. You notice the built-in blocks has different colors, and here's the math drawer, and when you click on it, it shows you all the possible blocks that you can choose from. So we also have green for logic, so this would be Boolean values, and a pink color for text or strings. Okay, so if you wanted to add, if you wanted to do the addition operator as your expression, then you could drag that out from the math drawer. Let's take a look at how to do that. So here I am in blocks. Here's my math drawer. I'll grab out an addition, and up here are your literals, which you can drag and place inside those sockets. You can click inside and put in any numeric value that you want. You can put in integers and you can put in decimal values. Let's take a look at how App Inventor will do an assignment statement then. Notice you got your set, and this just happens to be green. That's because we're setting component. So to the left hand side, we're setting the text property of a label for output. And then we're doing on the right hand side here, we're doing a subtraction operation, a multiplication operation, and a division operation. You can also do this and not have the literals like we have here. So in this program here, when the button calculate is clicked, the input is gotten from the user, which is typical. Very rarely do you use literals here. And so we've got a text box with how many miles has been driven, and another text box where the user's keyed in the number of gallons used. So that's divided into the miles and assigned to the text box MPG. So it's calculating the mileage of your car. Sometimes you need more than 2 operands. So each socket represents an operand in my statement. The multiplication and the addition block has this symbol called mutator blocks. Clicking on this symbol allows you to drag additional numbers into your expression. Let's demo that. So here I had that earlier expression, and I just grabbed this number, and how many do you need? And you keep dragging. Okay, and then you'll probably need to get additional values in there. Now, additional values doesn't have to be literals. If you end up dragging too many, you can always just grab and drop in the gray and it removes them. So you can add, you can remove. Clicking on this again will close that out. So as you see, just the addition and the multiplication values have there. Well, we'll see the min also has that. If your expression requires multiple operands, then what you're going to do is you're going to drag out multiple blocks, and this block, which contains the addition, becomes inside this socket for this block, which is division. Let's demo that. So I'm going to pull out a division and place that right in there. Let's put a different value in there. And now I've got my literal, and I'll divide that by 3, so that's averaging those 3 numbers. You've probably heard of formatting a Word document, and formatting a Word document means improving the appearance of the output. And the same thing can happen with programmers. Programmers want to improve the appearance of the output. Many times when you divide by 3, you're going to get a result like 16.33333333, where that 3 can go on forever. In App Inventor, most programming languages, you're going to see the 3 extend till the end of the label or the end of the text box. Not quite the output you want. So one way to format your output is to grab this. You notice it's blue, so it's in the math drawer. And this first socket is simply your mathematical expression like you had earlier. And then there's a socket below it named places. And so you can place here a literal, how many decimal places you want displayed. So there are other types of format. Just like in Word, you might have line spacing for format and bold for format. In programming, you might format for the number of decimal places. You might format for the comma separator in the thousands, or currency, you might show the $sign. A function, if you recall, will receive input and process that input. Now, we don't necessarily need to know that instructions. As a programmer, though, you will need to provide the input and you'll get the output back so that you can further process that. A very common function is the square root function. It's easy to understand. So suppose I'm going to call the square root function and supply the value of 36 as input, and what will come out? 6. If 81 were input, 9 would be the output. That value, 36 or 81, provided by the programmer calling the function, is called an argument. So an argument then is data sent to a function. Later on, you're going to find out that you might need to write your own functions. So functions could be something that someone else wrote for you, or something that you wrote. But that argument being sent has to be stored in a parameter variable. So data sent to a function is stored inside a function in a variable called a parameter variable. So event handlers are very much like functions, and they also have data that's available to you when that event happens. So in your paint pot, you might have had a touched event happen on a canvas object, and you had available to you where it was touched. Let's take a look at exactly what X and Y mean. You may have heard of the Cartesian coordinate system. In the Cartesian coordinate system, you had an x-axis and a y-axis. And the intersection of the x and the y-axis right here contain the value 0, 0. And you might have written those as ordered pairs. Now let's relate that to your Android rectangle. So a canvas component is a rectangle that you can write on, such as a painting canvas. And the corner of this rectangle, the left top part of that rectangle, is 0, 0. And what are the units of measurement? So if you call in Cartesian coordinate systems, you have units of measurement. In most GUIs, you have these rectangles, and these units of measurements are pixels. So if your user touched a certain place on a canvas, that's going to have an X value of how many X pixels over it is, and Y value of how many pixels down it is on your canvas. You can use that in your program to decide to do something right there. So maybe you want to draw a circle right there, or maybe you want to start drawing on your canvas, and you got to know exactly where they're touching at, and there's where you want to change the color of that pixel to red. So here are a couple more parameter values. So when you drag on a canvas, that's an event, you have all of this data available to you. Okay, so start X and start Y are where initially your user started touching the canvas. Prev X and Prev Y is the original place your user started the latest dragging event. Current X and current Y where they stopped. And I don't know if you've heard of a sprite, but dragged sprite, a sprite is just an image that can move. So maybe you have a circle or something that you're moving around and want to do something to. So this data is being used, Prev X and Prev Y, current X and current Y, to draw a line. And here we have the touched event where again there are 3 parameters storing the value sent of X, Y, and the touch sprite. Okay, now about data that you can create. So variables again have scope. Scope is where in the blocks you can use your variables. In App Inventor there are 2 types of scope, local and global. A local variable will be created inside an event handler, inside a method, or a function, and it can only be accessed. The data can only be grabbed from that variable inside of that method. In fact, the variable no longer exists as soon as the method is done executing. A global variable is created outside of a method, and it could be accessed by many methods and functions, and it exists as long as your program is executing. So to create a variable, you notice we also have a variables drawer. And here is how you would create a global variable. Now I want you to notice there's no notches here. So this stands alone outside of any other block. And here's how you create a local variable. And there are notches. This must sit inside a function or an event handler. So here's some local variables. And here's a local variable. You see how the notch fits in right here. Okay, and we have a local variable that we're dragging here. And you do want to give your variables a good name, and unless you're storing someone's name is not a good name. So you just click inside and you can change the name of your variable. Here we're assigning a variable and initializing the value of 25. You'll notice that when you grab a variable that you have this socket here, okay, and you should put an initial value. So here we're initializing it to numeric, and here is first name being initialized to text. You will see that you can also initialize variables to Boolean values and colors. When you want to do an assignment statement with a variable, you're going to go back to the variables drawer and you're going to grab this set block, and you will then select the variable right here. Now, local variables that are in scope and global variables will be available in this drop-down block. And then you're going to put in your expression right here. You're going to plug in your expression here. This block here is showing the variable miles being initialized inside the click event. So the local variable miles will only exist nested inside this orange block. The variable is being initialized to 0. Here it is assignment statement. And the assignment statement is using as input the results in the text box kilometers text property multiplied by this literal, and that will be assigned to miles. Then another assignment statement is happening, setting the text property of a different text box to the value that's in miles. What are some of the data types that you can have in App Inventor? Well, here is an example of assigning to a variable a string. Here's another example, assigning a color and a Boolean and a list. We'll get to that later, and even a time. So you'll see that quite a variety of data types are available to you. Just like the addition and the multiplication blocks, the initialized local variable blocks can have multiple variables assigned to it by using that mutator block. Let me demo. Okay, I'm going to click in the variables drawer and grab this, and you can just simply keep adding variable names, as many as you need. So if I needed a pay rate and hours, and then I'll click on this to remove it, and now I have two local variables for this method. Last of all, we'll talk about global variables. So to create a global variable, you can just set it out all by itself, and we have here a global variable called count. So why is count a global variable? Well, this is for an application that counts up or counts down, depending on if you click the up button or the down button. The up button is going to take whatever is in count right now, add 1 to it, and the result gets stored back in count. So count starts at 0. I click the up button. 0 plus 1 is 1. Count will now hold the value 1. Click the up button again. Well, count is holding the value 1. You add 1. Count will now hold the value 2. The down button does the opposite. It grabs whatever value is currently in count and subtracts 1 from it, assigning the value down in count. So why is it global? This variable is needed in 2 event handlers, and because it's needed in 2 event handlers, this variable is global. So that is the beginning of introducing building blocks in App Inventor. So I hope you'll be able to create expressions and write assignment statements in App Inventor.